Hello everybody, I'm Abul Fazbazatpur, and in this video, in continuation of the previous topic, I'm going to talk about the naming of coordination complexes. In the previous video, the names of different ligands were discussed when placed in the primary coordination sphere. In this video, we want to show the way and method of the naming coordination complexes. To do this, it is enough to remember a few simple rules. Nomenclature rules of coordination complexes. The first rule: always write the name of the cationic part first and then the name of the anionic part. For example, in this complex, this part is cationic part and the sulfate is the anionic part. Then in the naming, we can say that hexa aqua iron 2 sulfate. In the next example, the potassium is the cationic part and the ion complex is the anionic part. Then in the naming, we can say that potassium tetrachloroplatinate 2. It is possible that both the anionic part and the cationic part are ion complexes, like this example I gave. Then we can write first the cationic part and then the anionic part in the naming as hexa aqua iron 2 tetracyanonickelate 2. The second rule: in both the cationic and anionic parts, we have to bring first the name of the ligands and finally the name of the metal. In this example, we have a cation complex and we can say that hexa aqua, the ligand name, and iron 2, the metal name. In the other example, the both cation and anion parts are ion complex. Therefore, we must observe both the first rule and the second rule at the same time. In the cation complex, hexa aqua, the ligand name, and iron 2, and in the anionic complex, tetracyano, the ligand name, and nickelate 2 as the metal name. The third rule: when we have different ligands, we will write the name of the ligands in alphabetical order. Now, in this example, we have two ligands, aqua and chloro. So, according to the alphabetical order, the name of aqua should be given first and the name of the chloro should be given later. Tetra aqua dichloro iron 2. In the next example, we see more ligands: aqua, amine, bromo, and chloro. It is clear that according to the alphabetical order, AM in amine has priority over AQ in aqua. Then we can say diamine, diaqua, bromo, chloro, iron 2. The fourth rule: we'll use appropriate prefixes in the nomenclature to indicate the number of identical ligands, and we will do as the following table. If we have the monodentate or simple ligands such as amine, chloro, bromo, hydroxo, aqua, cyano, carbonyl, we have to use the prefix di for 2, tri for 3, tetra for 4, penta for 5, and hexa for 6 number of ligands in nomenclature of complex. So, but when we have the polydentate ligands or complicated ligands such as oxalato, bipyridine, phenanthroline, ethylenediamine, triphenylphosphine, triethylene tetraamine, EDTA, we have to use the prefix bis for 2, tris for 3, tetrakis for 4, pentakis for 5, and hexakis for 6 number of ligands in nomenclature of complex. It is better to examine examples in these regards. Cobalt En3 NO3 3. As you can see in the coordination sphere, we have 3 En, that means ethylene diamine, is bidentate ligands. Therefore, we have to use the tris as the prefix in naming. Therefore, following the previous rules, we can say tris ethylene diamine cobalt 3 nitrate. In the other example, we have Cu BPY2 Cl2. BPY is the bipyridine and bidentate ligands. So we have to use the bis as prefix for the BPY, and for the simple chloroligands we have to use the di prefix. Therefore, following the previous rules, we can say bis bipyridine dichloro copper 2. And one more example, PD PF32 Cl CO NO3. The trifluorophosphine contains 2 words, phosphine and fluoro. So it is not considered as simple ligand. And we have to use bis as prefix in the naming of complex. Therefore, following the previous rules, we can say carbonyl, chloro, bis, trifluorophosphine, palladium 2 nitrate. How we can name the metal in cation and anion complexes? For this purpose, we divide the complexes in 2 categories. The complex with overall 0 or positive charge and complex with overall negative charge. The complex with the overall 0 or positive charge, we can use the common name of metal in naming. But in the complex with overall negative charge, we have to remove letters like IUM or UM from the end of the metal name and add the ATE in the end of metal name. Of course, in some cases, the name of the metal is completely changed. Now we will review examples of them together. Cobalt with positive or zero charge, cobalt, and with negative charge, cobaltate. Chromium, chromate. Iron, ferrate. Nickel, nickelate. Silver, argentate. Vanadium, vanadate. Manganese, manganate. Platinum, platinate. Copper, cuprate. And gold, aurate. Determination of oxidation state of metal. Determining the oxidation state of the metal is very important in the nomenclature, and for this purpose we must consider the overall charge of the complex and the charges of the coordinated ligands. For better understanding, we will have examples related to the determining the oxidation state of metals in coordination complexes. The first one, in this complex, the overall charge of cobalt En3 is 3 plus because of 3 nitrate anions. On the other hand, ethylenediamine is the neutral ligand, which has no effect on the overall charge of the complex. Then cobalt has 3 plus oxidation state, and we can write the name as tris ethylenediamine cobalt Roman 3 nitrate. In the other example, bromo and chloro have negative charge, and with considering the natural aqua and amine ligands and the overall zero charge of the complex, the oxidation state of iron is obtained 2 plus. And we can write the name as diamine diaqua bromo chloro iron 2. And in the next one, the overall charge of a complex is 1 plus because of 1 nitrate counterion. So we know that the trifluorophosphine and carbonyl are natural ligands. Then with the considering of the 1 negative chloro inside of the coordination sphere, the oxidation state of palladium is obtained 2 plus. And we can write the name of complex as carbonyl chlorobis trifluorophosphine palladium 2 nitrate. Now we wanted to naming the following complexes. K3 FeCN6 we can write as 3 K plus and FeCN6 with overall 3 negative charges. The important hint is Fe has 3 plus oxidation state and the iron must change to ferrate because of the negative charge of complex. Then we can write the name as potassium hexacyanoferrate Roman 3. And another complex, cobalt amide 2 amine 4 bromide. We can write as cobalt NH2 2 NH3 4 with positive charge and Br with negative charge, and we know that the NH2 is amido and has one negative charge. Then the cobalt has 3 plus oxidation state with the considering of overall 1 plus charge of complex. Therefore, we must use the common name of cobalt. Diamido tetraamine cobalt 3 bromide. In the another example, we can write as 2K cations and the complex with 2 negative charges. The anionic ligands are cyano with 1 negative charge, oxo with 2 negative charges, and peroxo with 2 negative charges. With the considering of the overall 2 negative charges of complex, we can deduce the 6 plus of oxidation state for the chromium. And so we must use the chromate for the metal name because of the negative charge of complex. Then, with considering of the alphabetical order, we can write the name as potassium amine dicyano dioxo peroxochromate Roman 6. Some examples of determination of the complexes formula. 3-ethylenediamine iron 2 tetrachloroaurate 3. In this complex, first we have to determine the parts of cation and anion. With considering 2 iron and aurate name, we can deduce the complex content iron 2 is cation part and the complex content aurate is anion part. In the cation part, we have just 3 natural ethylenediamine ligands, and then the overall charge of cation complex is 3 plus. And in the anion part, we have just 4 chloro with 1 negative charge, and the overall charge of anion complex is 1 negative charge. Therefore, to observe the neutrality of the whole compound, we can act like calcium chloride. In the other example, we have potassium tetrafluorooxochromate 5. In this complex, potassium is the cation parts and tetrafluorooxochromate 5 is the anion part that have 4 fluoro and an oxo ligands. With considering to the 5 plus oxidation state of chromium, the overall charge of anion part obtained 1 negative charge. Therefore, to observe the neutrality of the whole compound, we can act like potassium chloride. Including a structural isomerism in nomenclature. For a significant number of complexes with the same molecular formula, there are structural isomers that must be mentioned in the nomenclature. For this purpose, we examine examples together. PtCl2 amine 2. For this complex, there are two cis and trans structural isomers. Then we can say that cis diamine dichloroplatinum 2. And for the other isomer, we can say that trans diamine dichloroplatinum 2. In the other example, we have two structural cis and trans isomers. Then we have to use the cis and trans prefix in the naming of the isomers. Trans diamine tetrachlorocobaltate 3 ion and cis diamine tetrachlorocobaltate 3 ion. If we have three similar ligands in the octahedral complexes, we will have two facial and meridional structural isomers. So we will use the prefix phos and mer in the naming of its isomers. Phos, triamine trichlorocobalt 3, and mer, triamine trichlorocobalt 3. I hope that the content of this video has been useful for you. Don't miss my next video on the naming of polynuclear and polymeric coordination complexes. Bye bye.